In this video, we are going to see about what is paired t-test in hypothesis testing. What is paired t-test? If the groups come from a single population, example, measuring before and after an experimental treatment, perform a paired t-test. For example, there may be instances of the same patients being tested repeatedly, before and after receiving a particular treatment. A paired t-test, also known as a dependent or correlated t-test, is a statistical test that compares the averages, means, and standard deviations of two related groups, to determine if there is a significant difference between the two groups. A significant difference occurs when the differences between groups are unlikely to be due to sampling error or chance. The groups can be related by being the same group of people, the same item, or being subjected to the same conditions. Paired t-tests are considered more powerful than unpaired t-tests because using the same participants or item eliminates variation between the samples that could be caused by anything other than what's being tested. Formula for paired t-test. To compare the means of two related groups or samples, use the paired t-test formula. The procedure of the paired t-test analysis is as follows. 1. Calculate the difference, d, between each pair of value. 2. Compute the mean, m, and the standard deviation, s, of d. 3. Compare the average difference to 0. If there is any significant difference between the two pairs of samples, then the mean of d, m, is expected to be far from 0. The paired t-test statistics value can be calculated using the following formula. T equals m divided by s divided by square root of n, where m is the mean differences, n is the sample size, that means size of d, s is the standard deviation of d. We can compute the p-value corresponding to the absolute value of the t-test statistics, t, for the degree of freedom df equals n-1. What are the hypotheses of a paired t-test? There are two possible hypotheses in a paired t-test. The null hypothesis, H0, states that there is no significant difference between the means of the two groups. The alternative hypothesis, H1, states that there is a significant difference between the two population means, and that this difference is unlikely to be caused by sampling error or chance. When to use a paired t-test? Paired t-tests are used when the same item or group is tested twice, which is known as a repeated measures t-test. Choose the paired t-test if you have two measurements on the same item, person or thing. Some examples of instances for which a paired t-test is appropriate include the before and after effect of a pharmaceutical treatment on the same group of people. Body temperature, using two different thermometers, on the same group of participants. Standardized test results of a group of students, before and after a study prep course. Examples of paired t-test. Example 1. A study was conducted to determine the effectiveness of a weight loss program. The table below shows a before and after weights of 10 subjects in the program. A. Is this program effective for reducing weight? Use a 5% significance level. B. Construct a 95% confidence interval, and determine the margin of error. Solution. Step 1. Define null and alternative hypothesis. H0, mu d, greater than equals to 0. HA, mu d, less than 0. Step 2. Find the differences of the two samples. Step 3. Calculate sample mean of the differences. Step 4. Calculate standard deviation of the differences. Step 5. Now the alternative hypothesis is mu d, less than 0. so we are going to use the left-tailed t-test. Alpha equals 0.05. df equals n-1 equals 10-1 equals 9. T, 9, 0.05 equals. Let's go to the student t distribution table to find the t value. Which will be 1.833, as we are using left-tailed t-test, so, minus 1.833. So, t critical equals minus 1.833. Step 6. Calculate our sample t-value, and compare it with the t-critical value. T equals, minus 13.1, divided by, 13.025 divided by, square root of, 10, equals minus 3.18. So, the t-value is in the rejection region. Hence, we can reject the null hypothesis, and can accept the alternative hypothesis. Step 7. Confidence interval equals m plus or minus, t multiplied by sd divided by square root of, n, equals minus 13.1 plus or minus 1.833, 13.025 divided by square root of, 10, equals, minus 20.65, minus 5.5. So our confidence interval is, minus 20.65, minus 5.5. Our null hypothesis is mu d greater than equals to 0, which does not lies in the confidence intervals. Hence we can reject the null hypothesis. Example 2. For example, 20 mice received a treatment X for 3 months. The question is to test whether the treatment X has an impact on the weight of the mice at the end of the 3 months treatment. The weight of the 20 mice has been measured before and after the treatment. This gives us 20 sets of values before treatment and 20 sets of values after treatment from measuring twice the weight of the same mice.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.